Hello everyone, this question is about vectors. The equations of two straight lines L1 and L2 are, we just use column vectors, 1 minus 2, 3, plus lambda times 2 minus 1a. And the second vector, minus 1 minus 1 minus 1, plus mu times 3 minus 2 minus 2. So just use column vectors. And this vector is called the point vector. It's a point on the line, and this vector is the direction of the line. So perpendicular means the dot product of the direction vectors should be 0. So the dot product of the direction vectors of the two lines should be 0. So we use the direction vectors, dot product equals 0. And if you look at the MF19, dot product is this formula. So A dot B is A1 B1, which means the x component of this vector, x component of that vector we multiply. So x component times x component, 2 times 3, minus 1 times minus 2, 8 times minus 2 equals 0. So after you solve the algebra here, you get the value of a. So this is 8, and you divide by minus 2, so you get the value of a. So this proves that the a is 4. And now L1 and L2 also intersect. So intersect means we equate both line equations. So the first line equation equals second line equation, and we have 3 equations for each component. For the x component, we have 1 plus 2 lambda equals the x component for the second line, minus 1 plus 3 mu. First equation. Second equation, minus 2 minus lambda equals minus 1 minus 2 mu. So from the first 2 equations, you can substitute, eliminate to solve the lambda and mu. So we multiply the second equation by 2 here. So times 2 times 2 times 2 times 2, we get this. And rewrite the first equation. We have 2, also 2. We can just add because we can cancel out. And on the left, we have only 1 plus minus 4, which is minus 3, and minus 1 plus minus 2, which is minus 3, and 3 plus minus 4, which is minus 1. So now we can add 3 to both sides. You get 0, so the mu is 0. And to find the lambda, you can plug into one of the equations. I'm using this equation here. We replace this mu with 0 because we know that the mu is 0. So this is just 0. You can minus 1 both sides and divide by 2. You get the value of lambda. And now we can use the third component. So 3 plus 4 lambda equals minus 1 minus 2 lambda. We have this equation. We plug in our mu and lambda value, and we verify that the lambda and the mu values agree with the third equation. Okay, so it checks this is right. We have the right value of mu and lambda, which means the line intersect. And for the intersection point, you can just use one of the equations. You can use the first or the second equation. So if you use just the second equation, this is 0, so of course you get minus 1 minus 1 minus 1. But if you want to use the first equation, you will also get the same thing. Next, show that A lies on L1. So to show that a point lies on a line, just plug in, you will get the same value of lambda. So if you use the x component, 1 plus 2 lambda equals minus 5, you will get the value of lambda, which is minus 3. And if you use the second equation or third equation, you will also get the same value of lambda. Or just plug in this value of lambda to the second equation, replace the lambda with -3, and you show that the lambda satisfies the second and the third equation. So next part, the point B is the image of A after a reflection in a line L2. So to visualize things, just draw something. So this is L2, the line 2, and B is the image of A. Let's say this is point A, and if it's an image, of course the L2 is the mirror, this is the object, this is the image, so it's gonna be like perpendicular, and it's the same distance from the mirror. Now usually we have to find the foot of perpendicular and then find B, but if you look at the first few parts of the questions, we already know that the L2 is perpendicular to L1, and we already know that the point A lies on L1, and we already know that the intersection point of the two lines is -1, -1, -1. So we already know this point. So this is actually the foot of the perpendicular. So to find the coordinates of B, just use this concept. So we have a point A here, and we have the mirror here, and we are finding the image here. So because the distance will be the same, just look at the process. From -5 to -1 we have to add 4. From -1 to to 1 to -1 we have to -2. Just look at the process as you go from this point to this point. What is the process? And we do the same exact process from this point to this point. So this is the image. So the position factor is -3, -3, 7. In column factors, you can just use this, or you can use this form. Alright, I'll see you again next time.